If metamorphic rocks are subjected to even higher temperatures and pressures, they can reach their melting points and transform into molten material called magma. Magma is a mixture of molten rock, dissolved gases, and solid mineral crystals. Magma can form through processes such as decompression melting, due to the decrease in pressure, flux melting, which is when water or other volatiles lower the melting point of the rock, and heat transfer from nearby magma bodies. As magma rises towards the Earth's surface, it can intrude into existing rocks, creating igneous intrusions or plutons. These intrusions can take various forms, such as sills, otherwise known as horizontal intrusions, dikes, otherwise known as vertical intrusions, and batholiths, otherwise known as large, deeply buried intrusions. When magma reaches the surface, either through volcanic eruptions or by intruding into shallow crustal levels, it is called lava. Lava cools and solidifies rapidly, forming extrusive or volcanic igneous rocks. Examples of extrusive rocks include basalt, andesite, and rhyolite. Alternatively, if magma remains trapped beneath the Earth's surface, it cools slowly, allowing larger mineral crystals to form. This process results in intrusive or plutonic igneous rocks, such as granite, diorite, and gabbro. The size and arrangement of mineral crystals in these rocks depend on the cooling rate, with slower cooling allowing for the growth of larger crystals. Exposure leads to the continuous exposure to rocks to weathering agents, such as water, wind, and temperature variations. Weathering processes, both physical and chemical, gradually break down rocks into smaller fragments, initiating the rock cycle once again. The exposed rocks undergo erosion by various agents, including water, wind, ice, and gravity, as described earlier. These erosional processes remove the weathered materials and transport them to new locations, starting the cycle anew. Denudation refers to the stripping away of the Earth's surface materials through erosion and weathering, ultimately leading to the formation of sedimentary basins or the exposure of underlying rock formations. Denudation can occur through multiple mechanisms, including fluvial erosion by rivers and streams, glacial erosion, coastal erosion, and mass wasting processes. Over time, denudation shapes the Earth's surface, creating diverse landforms, including valleys, mountains, plateaus, and plains. The rock cycle is intimately linked with tectonic processes, which drive the movement and transformation of Earth's lithosphere. Plate tectonics, the theory explaining the movement and interactions of lithospheric plates, plays a significant role in the rock cycle. Tectonic forces, such as divergent plate boundaries, where plates move apart, or convergent plate boundaries, where plates collide, uplift rocks and expose them to weathering and erosion. At divergent plate boundaries, where new oceanic crust is formed, volcanic activity brings magma to the surface, leading to the creation of igneous rocks. As the lithospheric plates move apart, the newly formed oceanic crust can be subjected to weathering, erosion, and deposition, eventually forming sedimentary rocks. In contrast, at convergent plate boundaries, where plates collide, rocks are subjected to immense pressure and temperature, leading to the formation of metamorphic rocks. Subduction zones, where one plate is forced beneath another, can also result in the melting of rocks, producing magma and generating igneous rocks. Additionally, transform plate boundaries, where plates slide past each other horizontally, can cause shearing and faulting, leading to the formation of fault breccias and cataclysards, both of which are types of rocks formed through mechanical fragmentation. The recycling of rocks through plate tectonics is an essential process in the rock cycle, facilitating the exchange and transformation of materials between Earth's interior and surface. The rock cycle is a continuous and dynamic process that illustrates the intricate transformations rocks undergo over time, from weathering and erosion to deposition, lithification, metamorphism, and igneous rock formation. The rock cycle encompasses various geological phenomena that shape the Earth's surface and interior. Understanding the rock cycle is crucial as it provides a framework for interpreting Earth's history, deciphering the formation of landscapes, and identifying the interconnections between different Earth systems. By comprehending the rock cycle, geologists gain insights into the ever-changing nature of our planet and contribute to the exploration and interpretation of its geological heritage. To comprehend the vast expanse of Earth's history, geologists employ the geological timescale. A chronology of it divides the planet's existence into